All right, number 64 reads, three forces are acting on the ring in figure 23. What is the net force acting on the ring? So here's what I got. I got this ring. I got a force going this way, and it is 64 newtons. I got another force opposing it. That is 128 newtons, right?
Yeah.
And then I have this third force that's coming off at an angle of 30 degrees.
That's 128 newtons too.
128. Thank you. And here's my axis. We'll look at that. It's not like spot on. Close enough. Okay. Here's what I got. I'm not going to deal, this is my method to finding this out, because you're asked what is the net force acting on the ring. What is the net force? The net force is equal to the summation of all the forces. I love questions like this. So I have all these forces and I'm trying to find the net force. Now with that, you need to find an angle if it has it, and a magnitude, and a direction. So I got to choose my direction. This is what I'm going to pick. This is my problem and I'm solving it. To the left is positive, and I'm going to make up positive. I mean to the right is positive.
I was like, wow.
To the right is positive, and up is positive. So this force here going to the left is now the negative. You need to deal with these only in the directions that they're going. So X direction and Y direction. So we're going to deal with the X. I got a negative 128 Newton, and it's the summation of all of those forces. I got positive, so add a 64 newtons, which will equal, if you do that in the calculator, I did it earlier, 64 newtons.
Would it be negative
What is it?
64?
Yeah, sorry, my bad. I'm doing horrible, and this is all on camera.
Wait, is this on camera?
Yeah.
Are you gonna like leave the
Hi,
words?
Kenzie.
Huh?
Are you leaving the words?
You have to explain it.
Where are
Hi,
you putting
Kenzie.
it?
I hope you feel better.
But what?
Where are you putting the video?
Are you gonna edit
It'll be
it?
on, I'm going to try and put it on YouTube.
So
and
can you
send
hear
it
our
out.
voices?
Cool.
Huh? Yeah, you can hear what you're saying right now.
Hey YouTube.
Make us famous. Please
Follow
like
me
and
on
share.
Instagram.
This way.
He's holding
Alright.
against our will.
Shut up, Whitney.
Oh, so Kenzie can listen.
Yeah, that's.
This is to help y'all study
Why do you
too.
think I said?
So we got this new force of
Almost.
negative 64 newtons, and that's in the X direction.
Yeah.
So this is what we're looking at now.
Miss Powell is so proud of you.
I hope she watches this video.
She's like your first subscriber.
No, actually she wasn't. She can't. Okay, so now I have negative 64 newtons in the X direction. I still have this one at the 30 degrees. And it's at 128 newtons. Guess what we got to do?
Man.
I guess.
So,
Trigonometry. Yay, we want to do Sokotoa.
This is on camera.
Alright, so we have the force here at X component and the force of the Y component. So what I'm going to do is just break this off into a triangle. Here's my triangle. my right angle. Here's my hypotenuse, 128 newtons. I'm trying to find F sub x, and I'm trying to find F sub y. Here. So, what you going to do? Trigonometry. Because we got this angle right here at 30 degrees. So let's do the sine of 30
Dude, this is nice.
equals the force of sub y divided by 128 newtons. All I did is just, the sine is the opposite over the hypotenuse. That's all that is. Multiply by 128, so I'll find F sub y equals the 128 newtons times the sine of 30 degrees.
It's like negative 126.468. Square.
Yeah, I know you're trying to act like.
Oh, I'm in radians.
I got
Oh,
64.
radians,
64 newtons.
do you want us in radians or degrees?
Where I'm in degrees, same with the degrees. I'm not going to give you radians, I will give you degrees.
Okay.
You got through trig, and most of y'all are in calculus now, so you're going to deal with radians again. What's heard you actually made it to trig today. It's the limit. Congratulations. Alright, so I got the force of sub y.
Is that what you guys do? Just talk about your classes?
Yeah. Right. Alright, so force sub y,
64.
64 newtons. Alright, now I got to find the force of sub x. I'm going to do that. Let's do it in green, just to be different. Force of sub x equals, okay, here's the triangle. I'm going to do, oh man, hold up a second, let's do this. Okay, cosine of 30 degrees is equal to adjacent, which is F sub x, over the hypotenuse, which is 128 newtons. So force sub x is equal to 128 newtons times the cosine of 30 degrees. And you'll find that to be I get 110.8513 newtons.
A lot of big newtons.
And then, do you add them together?
Nope. Hold up. So I found force of sub x to be 513 newtons.
Like me.
Now I have these components. When you're saying add them, which ones are you talking about add?
All of them are good. Like,
You can only add the ones that are in the same directions.
so,
So
No.
that one,
we're going to add these x directions together, and we'll add the y directions together. What do we have in the y direction?
128 and 64.
128 will be.
This is broken up now. This is no longer here. We broke it up into the component
so
vectors.
64.
So we're left with the 64. I'm going to circle it perfect.
What do you mean we no longer have?
Because what we've done is, you remember with vectors, vectors add up to equal resultant vectors. This is our resultant vector here. But I can't solve information for it the way it is, so I broke it into the components,
Okay.
the x and the y. So now, this 128 is no longer important to me, because I have the two components. It still exists, but I'm dealing with the components of everything there. All right. So we're now going to add all the x forces in the x direction together. So sum of forces in x direction. Which is negative 64 newtons plus positive 110.8513 0.8513 newtons, which that's what we saw for the force component, the X component. So I get 46.8513 newtons. This is in the X direction.
Somebody ate some of it. Mr. Hall,
Huh?
did you eat some of the big ones?
I did. I ate some big newtons. Okay, then we gotta deal with what's in the Y direction.
64.
Just 64. There's nothing really to sum up because it's the only force in the Y direction. So, force in Y direction is 64 newtons.
Do we add them together now?
We do not, because they're in opposite directions. That's where this comes in at. That you're looking, this is in the X direction. This is in the Y direction. Sounds like about both. Okay, so X direction, Y direction. Guess what we got?
Forces.
We has us a triangle with the forces.
Yeah.
So will that force be your hypotenuse? Yes. So I did something right. So why can't we, can we just do this like the Pythagorean theorem? We ain't gotta do anything fancy.
That's what we're going to end up doing. Because this is what we're going to end up with. Okay, so right now what do we have? Let's go in the X direction like what I taught with summing up these vectors. So let's start with the X direction, 46.85. So 46.8513 newtons. I'm going to use tip to tail. I'm going to go from the tip of my X direction vector and go to my Y. So it's going to go up 64 newtons. That makes me a right angle right there. And you go from the tail of your first one to the tip that you had.
Yeah.
So
Is there a certain sign we do for net force? Is it Fn? F little tiny n?
F net, that's what I do.
Well,
Okay.
I want to know if in the back of your video we can have the waves that you're playing
No,
for your subscribers.
no.
Ultra.
I start singing.
So I have to y'all edit the videos.
It's your
All right.
phone.
Can you find that? Absolutely. Pythagorean theorem.
Easy
Easy peasy, baby. Y'all done this enough. So force net squared equals.
A squared plus B squared.
Okay, y'all got this. Could I just jump to the square root of this
Yes.
thing? Thank
Yeah.
you.
Yeah.
So I'm gonna go equal to the square root of
Oh, you need to write
46.8513 newtons squared plus 64. Ooh, put the newtons in there. Newtons
that.
squared. And we're going to find that to be equal to hush, cornbread.
Do you even use this thing right here?
French press, absolutely. 79.3161 newtons. Now, this is the thing. You have the magnitude and the direction, but this force has an angle. You're in the second dimension. You have got to find the angle that goes with it.
Well, that's not hard. The sine of 64 over 79.
So we're going to try and find theta.
Come on.
That's what I said.
Oh, because they're
So
all-
let's find theta. This is what I'm gonna do. I'm not gonna use another piece of information I had to solve for. I'm gonna do the tangent. So the tangent of theta equals the opposite. So my opposite is 64 newtons. Divided by this right here, this 46 point adjacent, 46.8513 newtons. I'm trying to find theta. I gotta get tangent off of there, so I'm gonna take the inverse tangent. So theta is equal to the inverse tangent of 64 newtons by 46.8513 newtons. Find that to be equal to inverse tangent.
So do you want like a whole percent or do you
Why can't you do sine with that?
You absolutely could. I just did tangent.
I can get it.
Are you doing an inverse?
I tried the inverse just now.
We'll check it in. So we get 53.79 7939 degrees.
Yeah, that's the tangent. I don't see why you can't do the sine.
I wonder what if somebody watches this YouTube video, he's on the
opposite
corner.
over how cotton is? You have to use the-
I did.
You should go live with
Oh,
it.
I did it the first time.
No,
Why not?
I did it.
because if something said I want to delete, I can delete. All right, so final answer
Trust us?
will be the net force
Like, well, like.
Okay.
equals, where's our net force at?
Right, probably.
Right there, 79.3161 at 53.7939 degrees.
This is like coordinates.
Because we're in 2 dimensions.
You put your nose on 79?
I'm sorry.
You put your nose on?
Absolutely. Because units matter. My bad.
Manual.
So newtons.
We're gonna get used to this in 3 dimensions will pop up.
Whenever 3-dimension pops up is when we'll start dealing with torque, and that is,
What's that?
That's what I said.
we'll discuss that when we get there. You're not even close to ready.
I have a question that might sound stupid.
No, you're fine.
If this, say it ended up negative, technically, would it still be positive even though we're gonna keep it negative just because of our axis?
Are you talking net force? What do you mean?
You want to
Negative?
Yeah.
What would be
circle our
negative?
axis too.
Yeah, I want you to circle. Hold on. What, net force?
Yeah.
Yeah, it would. Yeah.
Even though there's no such thing as a negative force?
It is because forces are vectors. So they're giving you directions. So like if you had,
That's what I mean, just by the axis. But in
Yes.
reality, that,
no.
Yeah.
Because if I wanted to, I could have technically, like if I would have changed this over here, be negatives, then all this would change. But I didn't want to do that. Because then my life's complicated.
yeah,
Makes your head hurt.
I just think.
We got told about derivatives today.
That was just one problem.
Okay. Yeah, that's one problem right there.